So there are two types of problems you're going to be asked to work with in today's practice on the core practice sheet, and that is writing out a sum and then evaluating a sum. To write out the sum means I need to actually see the numbers and the plus signs that you're adding together, not just a final answer, but what numbers are you adding together? Show me these middle steps. So we're going to go here. I'm going to teach you a couple of shortcuts you should feel free to use. And by the way, there are patterns to many of these. And if you spot a pattern and you want to be able to use some sort of shortcut you come up with, as long as you understand how it works, that's a perfectly fine thing. So let's run through it. The first one we're going to do all by hand and write out all the steps so we can see how things go. So our index is A, our lower limit is 4, upper limit is 7. So for A, from 4 to 7. So I'm going to begin with a list of my A's. 4, 5, 6, and 7. And now one at a time, we're going to put those A values into this expression and see what comes out the other side. And I'm going to be super explicit here, so we're going to actually write it out. So 400 minus the first A value is 4. So that's going to be 396. The second A value is 5. So that is 395. Already, I'm willing to bet that you're able to spot some patterns. And then here. Now granted, this is not the world's most complicated expression, 400 minus A. If they are more complicated, writing out this middle step becomes more important. All right, now it's important that you understand what you're being asked to do. In this case, we are writing the sum. So the answer to this is the numbers added together. And you should put them in order from A equals 4, 5, 6, and 7. That allows someone who looks at your work to see, all right, this is an A was 4, 5, A was 6, A was 7. If they line up in that order, much easier to follow what it is that you're trying to say. Next up, let's do the same thing again. Now, if you are feeling confident that you know what's going on, I'd like you to do a quick pause and try it out on your own and then unpause when you're ready to check. This one, you've actually got some choices. You can leave it written here in the factored form where you have n times parentheses n plus 2, or you can do what I'm going to do. So from n equals 0 to 4, I'm going to distribute this n and call it n squared plus 2n. Both will give you the same answer. It is purely a matter of personal preference. So let's start with n equals 0, 1, 2, 3, and 4. I'll move that up just a little bit. And now is when I'm going to show you calculator trick number 1. And I'll use the handheld TI for this. I'm basically going to be doing the same thing 5 different times. I'm putting these numbers into here. So I could do them one at a time. I could say, all right, well, what is 0 squared plus 4 times 0? Well, okay, that's 0. That one wasn't that hard. But that means then for the next one, I'm going to have to type it again and type it again. Here is a trick that I like to use. Again, this is just to save time. You do not have to do this. If you want to save yourself a little bit of time, do this. Up here, we're going to, rather than typing in the number 0, I'm going to use a variable. And the easiest variable on these calculators is x, because if you press this button, you don't have to do anything else. It just puts an x there for you. So to start with, let's do 0 and store that as our x. So the store button is this one here, STO. It's kind of between your 1 and your 4. And then please do this for me. Press a colon. Now a colon is alpha decimal point. What the colon does is for your calculator, it says, all right, I've done one thing. I've stored 0 for x. So now when the calculator sees x, it will use the number 0. And the colon says, now I want you to do a second thing. And that second thing is, I want you to evaluate x squared plus 4x. And I'm just going to do a quick double check, make sure it was. Oh, see, I put a 4 on accident earlier. It was supposed to be a 2. That was just a mental error on my part. So this 4 up here should have been a 2. Let's change that to a 2. So the two things I did, I started with my lower limit of the index, so the 0, stored that for a variable. Now the index in the problem was n. We're using x. As long as it's a letter, it doesn't make any difference. Here then, I put in the expression x squared plus 2x. All right, so if I press enter now, the calculator has done two things. It says, all right, I know I want x to be the number 0. How much is 0 squared plus 2 times 0? Well, it's 0 in the end. Now for the next one, I want us first to do it by hand so we know what the answer should be, and then we'll see how the calculator gets us there a little bit more quickly. If I put 1 in now, 1 squared is 1, 2 times 1 is 2, 1 plus 2 is 3. So the result we're looking for is 3. Here's how the calculator makes it so simple. Press second enter. It's going to bring back what you had typed before. And now I just want to change the 0 in the x to a 1. And notice it gets us that 3 right away. Let's keep going. So for the next one, for n equals 2, 2 squared plus 2 times 2, well, that should end up being 8. Calculator, save us some time. Second enter brings it back, change the 1 to a 2, and it's going to give us that 8 on the other side. As you get better at this, it starts to go super quick. So bringing back this. Now when we put a 3 in, 3 squared plus 2 times 3, that would be what? 9 plus 6 is 15. Let's make sure that actually happens. Second enter brings back your previous line, change a 2 to a 3. There's the 15. And while we're here, let's put a 4 in. So second enter to bring it back. It should be what? 16 plus 4, or 16 plus 8 rather. So 24, there it is. And this one ended up being 24. So our sum then, 0 plus 3 plus 8 plus 15 plus 24. Again, you're communicating the sum here. It's not just about the end result. So yes, you do need to make sure you write the 0. That is a term in this series. So here was n equals 0, 1, 2, 3, and 4. N equals 0 up through 4. That communicates the sum we're after. Okay, let's go one more time. I want to show you now how to do a similar trick, but on Desmos. So let's bring it up. Let's see what we got. This time I'm going from m equals 5 to 9. So m equals 5, 6, 7, 8, and 9. Now take a look here. This is not hard to do. We don't even need to, well, we need to turn the lights back on. But you can do this entirely mentally. It's just taking 400 and adding on those different values of m each time. So let's not even overcomplicate. So this is going to be 405, 406, 407, etc., and etc. So for final answer, let's add them all up. Plus 406, 7, 8, and 9. So there we've communicated our sum. The problem is done. But like I said, I want to show you how to use a Desmos shortcut for a case where the expression is maybe a little bit more complicated. So coming over here to Desmos, what I care about is m. So as we've set it up here, just start off with m equals, and I think when we start with, was it 4? Started with 5, so it was 5 through 9. So coming back here, start with m equals 5. Just type in that. So what's directly underneath the sigma? That's what I type in. On the next line, type in the expression from the sigma notation. So m plus 400, m plus 400. Desmos knows that right now m is 5. So it tells you the first term in your series should be 405. Change the m to a 6. There's your next one. Change the m to a 7, 8, and a 9. It can get you those numbers super quickly. And the benefit is that this works even if the expression is something more complicated. What if instead of just m plus 400, it was m squared minus 2m plus 3? The same idea works. If you start with m equals 4, so there's what happens if m is 4. There's what happens if m is 5, 6, 7, 8. Can get you those different parts of the overall series sum very quickly. So the takeaways from here. When you're asked to write out a sum, we need to see the numbers in order with plus signs between them. As far as how you get those numbers, I want you to use whatever method is most comfortable for you. For a lot of these, it's fairly straightforward mental math. If you are using a handheld calculator, I recommend doing that little trick where you put in the number stored for your x, colon the expression, and then just press second enter and change your number each time. If you're using the Desmos calculator, type in the bottom of your sigma notation, and then type in the expression, and then just change the m value from case to case and get you those numbers straight away.